Alright, Unit 4 should be pretty fresh in your head, polar and vectors. So this is radical 3 comma negative 1, and I want a coordinate in polar, so I want r theta. So first thing I'm going to do is draw where is radical 3 negative 1. Radical 3 is the x-coordinate, negative 1 is the y-coordinate. That puts us down here. This is radical 3. This is negative 1. If I do Pythagorean theorem, radical 3 squared is 3, plus 1 is square root of 4, that's 2. So now I can look at it and say, if this is my reference angle and the sine of it is 1/2, then that has to be 30 degrees, which in polar we generally use radians. So I could say that this is the radius of 2, and the coordinate, or the angle, is either negative pi over 6, or I could also say 11 pi over 6, either way. So there's my coordinate in polar. Do the same thing here for negative 2, negative 2. That puts me down here somewhere, which I should immediately be able to say this is the side of a square. Negative 2, negative 2 is going to be 2 radical 2. This is 45 degrees. And now I know the radius and I know the angle. So 2 radical 2 is the radius, and the angle would be, this would be 4 pi over 4. One more is 5 pi over 4. Going the other way, from polar to rectangular, same game. 3, 7 pi over 6. 7 pi over 6 is right here, 30 degrees below the x-axis, and I know the radius, which is the hypotenuse, that's 3, and this is 30 degrees. Normally on a 30, 60, 90, this is 1/2, and this is radical 3 over 2, but this is not a unit circle, this is a 3-unit circle, so you need to multiply both of these by 3. Now you have the x and y coordinate, they're both negative because you're in the third quadrant, so negative 3 radical 3 over 2, and negative 3 over 2. I'm going to play the same game one more time here. Negative 2, 4 pi over 3. So if let's think about this for a second. Negative is tricky. 4 pi over 3 is down here. If it were a positive radius, that's what it would be. But since we're talking negative radius, we're actually up here at positive pi over 3. So this is a 60-degree reference angle for my triangle, and I know that the radius is 2. So normally across is radical 3 over 2, and across the part is 1/2, so we've got to double that. And I'm in the first quadrant, so everything's positive. That is 1 comma, the 2's cancel out, and you get radical 3 for your ordered pair. Rewrite each complex number in polar, or sometimes called trigonometric form. So to do that, I need to have both of these in trigonometric form, so I have to first convert them. This is 1 plus 1i and 2 radical 3 plus 2i. So let's get both of these converted. 1 plus 1i should be pretty easy to do. This is 45, 45, 90, and that's radical 2. So if it's 45 degrees, that's pi over 4. So in trigonometric form or polar form, it would be radical 2 cosine pi over 4 plus I sine pi over 4. Remember, we're graphing on the complex plane, so that's the real and imaginary axis, respectively. Same thing here, 2 radical 3 and then 2. This is 2 radical 3, this is 2, which if I do Pythagorean theorem, this is going to be 4 times 3 is 12, plus 16 squared 16 is 4. So now I know the radius is 4, and this is cosine of, what's the angle there? The sine is 2 over 4. The sine is 1/2, that's 30 degrees, so that's pi over 6, plus I sine of pi over 6. So now that I have Z1 in polar form and Z2 in polar form, I can find their product, and when you find their product, you have to multiply the radii, so that's 4 radical 2, cosine of, and then I have to add the angles. So pi over 4 plus pi over 6, in the denominator, that's 3 pi over 12 plus 2 pi over 12. So this is 5 pi over 12 plus I sine 5 pi over 12. And now I have, in trigonometric form, the product of two complex numbers. So it's 4 radical 2 cosine 5 pi over 12 plus I sine 5 pi over 12. One more to do. They're giving me a couple of vectors, and they're asking me to find some of their magnitudes. This should be an indicator that you're going to have to use the equivalent of the Pythagorean theorem here for vectors. So they're telling me that negative 2, 5 is one of my vectors, so I need to first find the magnitude of v. And the way you do that is you square negative 2 and you square 5, and that would be 4 plus 25. So the absolute value of v is 29. I could do the same thing to find the absolute value of w, which is 6 squared plus 8 squared. That's 36 plus 64, which is 100, and the square root of 100 is 10, because you have to square root this. Okay. If I want to find v minus w, let's do this in terms of I and j for a little review. Negative 2i plus 5j, and I'm going to subtract 6i plus 8j. So if I subtract that, it's going to be negative 2i minus 6i plus 5j minus 8j, which is negative 8i minus 3j. So now I have, in terms of I and j, my two sides. I need to find the absolute value of v minus w. So I need to do negative 8 squared plus negative 3 squared and square root it. So this would be the square root of 64 plus 9, which is the square root of 73. So the absolute value of v minus w is the square root of 73. Now the last one, it's important that you make the distinction here. This is not going to be the same as when I do the absolute value of each and subtract them. To find the absolute value of v minus w, I have the absolute value of v, I have the absolute value of w. So the absolute value of v minus the absolute value of w is 29, it's radical 29, radical 29 minus 10, and that's my answer. So that's it for polar and vector.